Assalamu alaikum guys, this is Nabisha Asha. Today I came to explain you about the unit 2 structure and bond. This is last previous presentation we have completed the unit 1. There we have spoke about what the atomic structure, right? Now we are going to speak about the imaginary process. So what is mean by the bond? How the structure is mean by? So first thing is we have to know about what the covalent bond. So here it is. In this presentation, we are going to speak about what the covalent bond says. Let's read it. First, we will go through the thinking. Here it is the introduction of what is mean by the structure and the bond. And we are going to speak about the different chemical bonds, how it characterized. Majorly, we are going to speak about yes, and second, next, major we are going to speak about the covalent bonds. Under the covalent bonds, the new rule, maybe I don't know whether you have studied in your O-level, it's the octet rule. How this octet rule is influenced in your structure and how the bonding going to be made. This is what we are going to study hereafter under unit 2. Let's move on to the introduction. The first thing is what I'm going to speak here is this unit is conceptual of what the structure, how the structure is made according to the bonds. Yes, and the chemical bond and structure of the molecule are, I already said, it's a conceptual model, right? Which is based on the modern atomic model. So we already studied what is the atomic model, what is meant by the atomic structure, how it's evolved, everything, right? So why we need about this chemical bond? Yes, in order to explain about what the physical and the chemical property of matter. Yes. So I said it's a kind of the conceptual model by being understand that model you able to explain about what the physical and the chemical properties of a matter. Many atoms, yes, we already said they do not have stable outermost valence shell configuration. Therefore, chemical bonds occur between atoms in order to achieve stability. So when you take any atom, right? Okay. So the hydrogen having only one. Is it a stable? No. One is become as a S2, then only you can conform. What? Yes, that is a stable configuration. What about this? Go for helium? Yes, that is 1s2, stable. So what about the lithium? Again, that is 1s1 and 2s. 1s2 and 2s1. Yeah, so how this stability can be? So without this table, they are unable to make what? The proper bonds. So by having the bonds only, we can speak about what the physical and the chemical properties. To obtain a stable outermost valence shell configuration, they undergo what? The bonds between the atom, we say, in order to achieve the stability. The following table, yes, will be explained about what the valence electron participate in different types of the chemical bonding using several acceptable models. So let's move on to the different types of the chemical bonds. Yes. So it's okay. So I need a copy. So I just remove it aside and keep it. So we have okay, right. When you speak about the types of the model, right? Okay. So first, we say why you want to understand about the chemical bonds. Yes, according to the chemical bonds, then only we are going to speak what such kind of the physical properties it can be have, right? Okay, and how for that sake, chemical and the physical properties, we are going to speak according to this chemical bond. And look at here. The first thing is the chemical bonds can be divided into three, right? You can see it's clearly here, Okay. So the first, how it's divided, the sharing of pair of electrons between two atoms. This is one method, right? So I will come what is mean by that later. Just wait. And second, they speak about what the metallic bond. Third, they are telling is complete removal of the electron from one atom to form a cation, and the acceptance of another atom is called its anion. I found one, but let's move on to the first one. It's not new. We have studied about the chemical bonds earlier, right? Okay, what is mean by the sharing a pair of electrons between the two atoms? The share, the word called share, it's simply you can understand what they are meaning here is. That is covalent bond. Yeah, what is mean by the covalent bond? Sharing a pair of electrons between two atoms in which each atom contributes to one electron. You should be very careful about that. Here, the pair of electron going to be you. Yes. Here, the pair of electron going to be shared between A and B. Right? You can say like that. Okay, I will show you. It's clear. Yes. A, B. And let me have another color to show you. Yes, between the A and B, one is cross. So they are telling the share of electron shared between two atoms. So the one electron, each atom will contribute the one electron. This is what we are calling as covalent bond, right? Okay, and go for next, the covalent bond. Again they said they are sharing a pair of electrons between two atoms. You are familiar with covalent bond. What about the dative bonds? What is meant by dative? According to this, the sharing a pair of electron, you can say the dative covalent bond, that is also such as a bond. We will study this very detailed inside of us. Not here, the separate presentation. So this is mean what? The sharing of an electron pair between two atoms in which the both electrons are given by one atom. We should be able to understand this very clearly. So the dative covalent bond means what? Here you have A and B. The A is giving the one pair electron to the B. One pair of electron, not one electron like your covalent bond. Right? So this is what we are meaning by the dative covalent bond. Okay? We have spoke about the sharing a pair of electrons. What is mean by the metallic bond? The metallic bond means what? The large number of metallic cations are stabilized by the cloud of many electrons. This is what simply we can say the metal can make the metallic bond. So here large amount of the cations, the positivity is there, as well as that positivity is bonded with what? Large amount of the electrons. So you can get a stable configuration of what? Yes, metallic bond. Right? Okay, and let's move on to the last one. Should be very important, and you know what is meant by that. In your O level, you studied about the two types of the bonding. One is the covalent bond, and what is another one? Yes, ionic bond. Yes, here we are going to speak about the ionic bond. Complete removal of the electron from an atom to form cation. If you are losing an electron, I say, right, that is cation. Another place, there is a person to accept that electron. For that sake, that atom will call as anion. So this is what we can simply say, it's ionic bond. So you can say this is as what type of the bond? Ionic bond or ionic interaction, or you can say ion attraction forces. So what is happening? The form due to the electrostatic attractive forces between the cations and anions. Can you say what is the charge for cation? The cation is a positive, anion is a negative. So this is positive, this is negative. So definitely between the positive and the negative, there should be the electrostatic, the attractive force, right? Because of that, this ionic bonding forms, right? Okay. And let me move on to the next slide. So what is mean by the chemical, sorry, the covalent bonds? Here, the majorly, we are going to speak about what the covalent bond. And let's move on to the next slide. Give me a second. I'm going to speak about the covalent bond. Already I said the covalent bonds form how? When a pair of electrons is shared between two atoms of the same element or the different element. I said, we already said what is mean by that. We already said, yes, what we said, what is mean by the covalent bond. Yes, the covalent bond means what? You able to share a pair of electrons, right, between the two atoms. Either can be what? The same element or the different element. So simply under the covalent bond, we are speaking the sharing of the pair of electrons contribute. Yes, I already said the one electron from the each atom to form the electron pair. So as you know, if you want to make the one bond means what? You have to contribute the two electron. That means one pair of electrons. So let's wait for a while. Right? Okay. So here I'm going to speak about what. So what is mean by the covalent bond? Yes. Simply you can say the covalent bond means is very important, right? The sharing the pair of electron. So can assume the A and B. The A can donate the one electron. The B will donate the one electron. This is what from this that will have stable configuration. This is we are using one covalent bond. And you already have an idea about this covalent bond when you study in your order, right? So the covalent bonds are formed when a pair of electrons is shared between the two atoms of the same element or the different elements, right? I say. So the sharing a pair of electrons contribute one electron from each atom to form the electron pair. I said if you want to form the bond, we need two electrons. That means the one pair of electrons. Consequent to the stable electron configuration are often achieved by both atoms in respect to total number of electrons in the realization. I have shown you we need the stable configuration. So what should be the stable configuration? What they are telling is, so to obtain, right, a stable configuration, what should be the number of valency electrons should be there in your valency shell? The question is there. Yes, fossil and Langmuir. Yeah, fossil Langmuir and Lewis stated the filling of electrons into a valency shell up to a maximum value of 8 results a stable configuration is all up to 2. So the word is very important. To obtain the stable configuration, again and again I am just prescribing that word that is a very much needed for the bond formation. So this unit we are going to speak about how does the bond, it's a kind of the conceptual, the imaginary process. You couldn't see in your naked eye. You have to imagine how the bond is making. What is the basic requirement for the bonds? Yes, we said as it is of saying the stable configuration. What is that stable configuration? Either 2, 8, 16? We don't know. So, these three scientists have stated if you want to obtain the stable electron configuration, that is what your valency shell should have up to maximum value of 8 electrons. That is what they are calling as octet. Yes. According to the electron configuration, we are going to speak about that. With these all atoms obeying the octet, how it's deviating. This is what we are going to speak here, right? The second period. So what is meant by the second period, guys? Yes? Anyone? Two. The 2 is the second period. When you consider, right? Okay? N is equals to 2, the number of shells. It's used to the second period. The second period means what? The maximum number of valency electron in 2s and the 2p. I said when you speak about the second period, we are going to speak n is equals to 2. The maximum number of shell should be 2. So here the electron in 2s. Yes. When you take the second period, right, you have this example. More likely, the octet rule should be obtained by the second period elements such as carbon, nitrogen, oxygen, and the fluorine. So, which is able to complete the octet rule. So, second period is finished. What about the third period? That's an exception. Second period, they can have the S and the P. S can have the maximum 2. The P can have the maximum 6. So, it's a very active. What about the third period? The valency shell of the elements in the third period, N is equals to 3. Right, I say. And subsequent period consists, you have to be under. Right. So when you take the second period, you have only the S and P above the 3. Right. But now you have G sub energy level also there along with your S and P. So what should be the problem? Yes, therefore, when forming a chemical bonds, there could be instances where the number of electrons in the valence shell may exceed 8. Why? I said when you take right, when you take the third orbital, the N is equals to 3. Therefore, you can have the S, 3s, 3p, and the 3d. Because of the presence of the d orbital, right, it can have 2, it can have 6, that is a maximum 10. So, it may be exceed the 8, so octet rule is not possible all the time in the third period of elements. So the example is the sulfur. sulfur dioxide and the sulfur trioxide. Right. So when you take the sulfur's valency electron is the 6. Once we made the bond, we'll be able to exceed up to what the 20. So let's see more. Next, such molecule, the number of electron, I say the valency shell sulfur is greater than 8. So we will speak about that. Without drawing that, you can understand. Just for the idea, I will show how the sulfur can make the bond. The sulfur trioxide, right? That means you will have oxygen, oxygen, oxygen. Yes, can have the double bond. So now you can check here sulfur, right? The all 6 valency electron went for the bond. And can you check here what is your valency electron configuration of the sulfur? Yeah. But here it doesn't matter. Oxygen all have 8. So this is acceptable. Why oxygen showing the octave group? Right? That is second period. Second period. But when you go for the sulfur, it's not obeying the octave group. I said why? This is when it's supposed to be. Can be exceeded, they already said. So this is what, and you don't know how can we show this this structure. You will study that later session. So the presence of the d orbital, why this exceeds this number of electrons? About it, I said the presence of the d orbital, you have the 10 extra along with your 2 and a 6, that means 8. The valence shell sulfur can permit up to 18 electrons. This is why it exceeds the octave group. Since the d orbital, what is the reason for that? The t orbitals in the valence shell also participate in the bonding. The number of valence electrons in the sulfur atom can exceed the octave. So this should be the rule, guys. Why we said when you take the second period, that is the maximum number of the electron can be permitted is 8. But when you step into the number 3, the third period, now the availability of the D along with your SP, the D also will be added. So you will end up with 8 electrons. So the sulfur or whatever the third orbital, the third period elements able to exceed 8 to 18. Why? Here the d orbitals also will undergo for what? The bonding. Right. However, for such atom, it is not always necessary for d orbitals to participate in bonding. It able the sulfur, that's why sulfur is allowing the d orbital to participate in the bonding formation. That's why it's exceeding the octave joule, but not all the time. It's not necessary to participate the d orbitals in the bond making. So let's we have the example about that. Look at your hydrogen sulfide H2S. Here the sulfur atoms complete the octet without involving the d orbital. Right. So guys, here also I just want to confuse. I don't want to confuse you all. So when you say the hydrogen sulfide, right? Okay, you have the sulfur. This is what the bond hydrogen, and you have what? 2 and there. So when you take the 2 lone pair, right? This is 2, 4, there's 6, and if you count together, it's obeying the octet rule. How I'm doing this is, there is a rule. This is what we are calling UV structure. I will explain you what the person is telling us. There are other situations where atoms of some elements do not necessarily complete the octet. We are telling that is the incomplete valency shell electron deficient compound. Simply we are speaking that is as an electron deficient compound. Who are they? The elements like beryllium, boron, aluminium, they unable to complete the octet rule. We are calling them as the electron deficient compound. Such compounds we are ultimately can see that incomplete the valency shell. Why you couldn't see the octet rule? In all instances described above, the number of electrons in the valency shell after forming the chemical bonds is an even number. That is very important. It should be all the even number, the odd number also there. So, however, it's not true. Why? We spoke about only the even number. You can have the odd number also. The nitrogen is the person who can permit the odd number of electron even without completing the octet. There are some exemptions, so you have to go through that one. Yes, the first thing we said the third period maybe exceed the octet rule, right? So not all the time there is a hydrogen sulfide, it is able to accept the octet rule. And second thing we studied what? Yes, we are able to obtain electron deficient compound, they are whole. You can see what incomplete shell valency shell here. So that is also we are calling it electron deficient compound. You couldn't see the 8 electron in the valency shell. That is who are they? Aluminium fluoride, beryllium fluoride, and the boron fluoride, right? And now I was speaking until now we will spoke about what? The even number of electrons. But you can have the odd number of the electrons that is also able to exhibit without completing the octet rule. So that is what nitrogen oxide and nitrogen dioxide, NO and NO. In order to understand how I am speaking about this bond, yes, how I am drawing these bonds, how it's visible. This is what you have to know the model. In order to understand the arrangement of the bond pair and the lone pair in molecules and ions, a model was introduced by Wilbert Lewis, known as Lewis dot structure. This is what we are going to speak later on part. Yes. How I drawn this complete structure without knowing the knowledge, you couldn't draw it. Yes, we have studied should ever able to gain the octet rule. So what are the rules? How can I draw along with two atoms involving in a bond formation? Yes, we are going to speak about the covalent bond under here, not any other chemical bonds, right? So according to that, to understand the arrangement and the bonds pair, right? Bond pairs and the lone pair in the molecules and the ions, you have to know the model, how you can able to draw this. That is introduced by what the Lewis, he said, Lewis dot structure. So we will study about this Lewis dot structure next presentation. Anyhow guys, thank you very much until we will meet with the next presentation, which we are going to explain you about how you can draw the chemical bond, right? For that sake, you should understand the Lewis dot diagram according to the plenty of rules. Anyhow guys, we will meet in the next presentation. Until then, see you. Bye bye. Assalamu alaikum warahmatullahi wabarakatuh. Thank you very much.